Hey, what's up, people? Happy 4th. Alright, yesterday we did continue working on code which will reconnect the client to the proper game. Works in server file, reviewed server file, don't understand it, it's been a while, consulted ChatGPT. Alright, yep, that's about right. Alright, need to add code which reconnects the client back to this thread without rerouting through the main process. We don't want this thread to be killed otherwise. Makes more sense just keep thread alive, reconnect speak on hostile reconnect IP port combo. Such that whenever the client is reconnecting it would always use the reconnect IP port, would reassign the con to the new connection and simply re-enter into the threaded main while loop. That's where we stopped. Read below and determine best course of action. Note from ChatGPT, check that ChatGPT thread again for more info. Pre-assign per match port for reconnects. So if we have multiple child processes, one for each game, do we need a different port? Well, apparently do we need different port for each child process? No, you don't have to assign a different port per game, but doing so is one way to let clients reconnect directly to the correct game process. Okay, right, yeah, so basically, yeah, duh. So each port would be essentially associated with, yeah, each port would be associated with a game because when they're reconnecting, if there was multiple games using the same port, well, then it would be the same IP port combo. So like, wouldn't that mean that, like, both of those processes, let's say we have those two child processes that have the same IP port combo, and someone had disconnected from each one of those games, whenever they went to reconnect, like, it wouldn't know which client to connect to which game. It would just, because the port and the IP is the same. Doing so is one way to let clients reconnect directly to the game process. When multiple ports make sense, each child process game match runs a small dedicated server socket on its own unique port, reconnecting clients directly to that port. This avoids funneling everything through the main process. Direct connection, no need for message forwarding. Isolation, each game has its own communication endpoint. Makes it easier to sandbox and monitor. In some cases, avoids bottlenecks from routing all traffic through a central point. Port exhaustion, TCP ports, especially on the are limited 60,000 megs. Practically much fewer firewalls and NATs are involved. Firewall NAT issues, more ports equals higher chance of network issues. More ports equals higher chance of network issues. More complex connection logic, clients must be aware of which port to connect to. One port, route internally. The main process is game ID, player ID, child process. Point reconnected validate token for child using IC. Easier firewall management, scales better across hundreds of games. No port exhaustion. Cleaner reconnection UX. Adds overhead and complexity to routing layer. The main process becomes a centralized dependency, a performance or failure point, unless carefully built. Client sends reconnect token, match ID, etc., and main process forwards. Okay. So if we had two child processes with same IP port combo, each with a DC'd client, when they go to reconnect, it wouldn't know which client it would know which game the client was associated with. If two child processes are on the same IP port combo, then only one process can actually bind to that. Okay, so you can't even do that. You can only have one process binding to that IP port. Those will reject any attempt by a second process to bind to an already used port unless special mechanisms like SO reuse port are used, which is advanced and platform specific. You cannot have two separate child processes listening on the same IP port. Only one process can own a port at a time. Therefore, to allow reconnections directly to the correct child process, you must give each child process its own unique port. Gotcha. Assigns a free port from a rotating pool 41,000, 42,000 gives both players this reconnect port and token. Player disconnects client app knows it can try to reconnect to that specific port, sends its token to authenticate and resume the session. Why do we need a token? You don't strictly need a token, but using one is strongly recommended for authentication. Without a token, anyone who connects to the child process's port can impersonate a player who got disconnected, potentially mess up the game state, cheat, or cause desyncs. Correct player identification. Even if someone reconnects to the correct port, child process, you need to know which player slot they are. Okay, that's right. And instead of using IPs, because we can't really rely on IPs, whether they're authorized to resume the game, a token removes ambiguity. Gotcha. Reconnect token that can be a simple string like match ID, player ID. The encoded base 64 data to be signed with a secret key to prevent tampering. Someone could spoof reconnect just by knowing the port. You'd have to rely on IP address, which changes on mobile Wi-Fi, game state, guesswork, risky manual user login. Clients could accidentally reconnect to the wrong slot or corrupt the game. A short-term session ID. Random UUID given each player when match starts. Store this in memory or config file on client and send on reconnect. Full token security mechanisms. The token ensures reconnections are secure, authenticated, and mapped to the right player without guesswork. Without it, you can reliably trust who's reconnecting, especially if multiple players reconnect to the same process port. Let me know if you'd like an example of how to generate and validate tokens in Python. Okay, so don't we already do that to us? Well, we don't give an actual token, but we give them a client number, right? A client ID. That's the first thing that they do, is receive the client ID. Yeah, and.get client in game ID. And the client ID is yeah, so the client ID is basically a token. Yeah, so the client ID is what they would need to contain. Like whenever they go to reconnect, they would need to send the client ID. So let's add that. So reconnect local. Do this before replaying all their save game. Yeah, so I can get rid of these notes here. Do this before replying all their to their other client. No, ASAP. The client is reconnected. And we need to say need to include client ID to let server know which client they are. Need to add code in server pi which handles asking for this, which handles receiving / expecting this client ID. Also to determine which client 1 or 2 is associated with. I guess we could do that based on like even or odd, right? Like if it's I mean, unless somehow that got like fudged, you know what I mean? Unless somehow there was some like fudging of the the flow of things. We don't want to necessarily like assume like client 1 is associated with 1, client ID 2's 2, client 3 is 1, client 4 is 2, client 5 is 1, client 6 is 2, so on and so forth. That doesn't necessarily like that could probably get messed up, right? In some weird scenario where I don't know. I think it would probably be safer to just actually have an association. You know what I mean? Like a dictionary that just associated each client ID with client number 1 or whatever. Or would that even need to be done? Like, wouldn't they just Well, I guess we could make it to where if the server, like, something messed up on the server and the game crashed, if they both got disconnected, whenever they went to reconnect, like, we would need to know which thread, you know what I mean? Like, which threaded client should pick them up. So let's add this. I'm pretty sure this needs to be taken care of. So we'll say refactor accept connection start threads. Since it probably won't handle reconnects anymore, we can modify it to reflect that. And then also server map client ID to client 1 or 2. Create a dict or other way to ensure upon reconnect that we are connecting the correct clients to the correct thread. So let's see. Overkill in case of just one. Client DCing. But what if both get DC'd due to network issue, server side or something? In this case, if they both attempted reconnect at same time, wouldn't be able to tell who was who. Therefore must have logic for threaded client reconnect section to check the client ID or a token or something to verify proper clients. Yes, and so what was I thinking about the crazy dictator? Okay, yeah, so so there's a couple questions. One of them, would it be possible for both clients to get DC'd simultaneously, causing both of them to attempt reconnect to same child process? So you can have one process per IP port combo. So it would just be shared among the threads. So then two, we can have two threads share same IP port combo, correct? Having two threads share the same IP port combo. And let's see. Two threads sharing the same IP port combo. But the guys are very event robust. Can both the clients get things simultaneously attempt to reconnect at the same time? This could happen due to network failure, Wi-Fi router resets, a server-side restart of the main process, a bug in the child process. If both client threads crash or disconnect simultaneously. Mobile power saving network switching behavior. What happens then? If both clients reconnect to the same child process and they provide valid, both can be reassociated to respective threads. But you need to make sure the child process supports reconnecting both clients independently. The player slots, player 1 versus player 2, are correctly identified. There's no race condition, both reconnect at the same time in overwrite state. So you'd have to lock or threading condition per player slot in the child process to coordinate safe reattachment of sockets. So if we had same port for both threads, then that socket would be multi-thread shared, aka needs a lock. Would it be better to have 2 ports, one for each thread? Use threading lock or threading condition per player slot in the child process recording. Can 2 threads share a same IP port combo? Yes, with important constraints. Multiple threads in the same process can share a single socket, but multiple processes cannot. 2 threads, same process, 2 process, 1 process binding to port, others connecting to it. One process binding to a port. Each child process binds once to a socket per reconnect port. Each child process binds once to a socket. Inside the child process, both client threads use the same socket, or each keeps their own accepted connection. They can each handle a socket object returned from accept on that port. Yes, if both threads are reading writing from the same socket object, you must synchronize with the lock to avoid data corruption or interleaving. One socket, one accept per thread, no shared socket object. The main socket bound to the port is used only to accept connections. So basically, at the start of the once the thread, or once the process is started, it would just well, I guess it wouldn't matter which thread initiated the creation of the socket. It would still be available to the other thread. Yeah, it would still be available to the other thread. But you wouldn't be able to create another binding to that port on the other thread, because that could only be done once. The main socket, one socket, one accepts per thread, no shared. The main socket bound to the port is used only to accept connections. Each thread gets its own connection socket after calling accept. Each thread gets its own connection socket. So yeah, they could still accept to that same port from different threads. You would just have to make sure that you're getting the right client that you're accepting. You know, you don't want to accept the wrong client, so you would just like check the client ID or whatever to make sure it's associated with, like, you know, the client that was connected to thread 1, aka client 1 or whatever. Only the server socket accept needs coordination. Only the server socket blah 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 blah. This is the cleanest approach. Shared socket object, one con between threads. If two threads are sharing the same socket object and both calling, yeah, we don't want to do that. That's silly. Should use 2 ports, 1 per thread. No, usually not necessary. The standard scalable pattern is 1 listening port per match process. Each client connects to the same port. The child process accepts both clients and hands them off to separate threads, each managing their own con. So 1 port per match, not per thread player. Each con from accept is separate and isolated. Perfect for threading. One process binding to port others connect to. Client server architecture, 1 process, usually the server game host, binds to a socket. Other processes connect to that port. Reserves a port and IP on the OS. Listen plus accept. Waits for incoming connections. And then the connect attempts to establish connection to remote IP port. In your case, a child process game match binds to a port. The client apps reconnect by connecting to that IP port. You never have multiple processes binding to the same port unless using advanced. Do shared sockets between threads need locks? Yes, but blah 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 blah. Should use 2 ports per thread. No, 1 port per match is process is enough. Okay, I thought it meant something else there. Okay, I got that figured out, I think. Server map client ID to client 1 or 2 create a dictator other way to destroy this. Reconnect to game client pi code reconnects to the proper game. But whenever it goes to connect, well, I guess what would happen is when the client attempted to reconnect, like whenever someone disconnected, whichever server-side thread the client disconnected from, that would cause the exception from the connection issue. Then that we would trigger the listening of that reconnect socket or whatever, or but we can't, like, before data transfer starts, they have to like connect first. So how do we connect without, like, how do we verify that they're the right one when they go to connect? Because connect, we just say local false network socket connect, and remote network endpoint. So is that what we use on the server side to connect? We say and connect. Is that what we actually use? Yeah. We use n.connect. Self network socket connect. Okay. All right. Oh my god. Oh my god. yeah, like we can't. How do we determine? I know that it said something about that, but like, how does it do that? See, because we accept first. Like, you have to accept before you can receive. So you just you create the connection, then you check, and if it's not, then you end the connection and do it again. So, but if both clients are DC'd and attempting to reconnect, then how, if both clients are DC'd and attempting to reconnect, then how do we verify which client is which prior to actually establishing the connection? Since we can't send the token prior to actual connection. Let's cover the difference between TCP and application level identity and how to safely and correctly reconnect after both clients. TCP connection is not equal to application identification. When a client reconnects to your server, the TCP connection is servers, but at that point the server knows only the IP and port of the remote client, not who they are in your game. The server must then read an application layer message, reconnect token or session ID from the client to know which player they are. You don't verify identity before the TCP connection is established. You verify it immediately after. So the client reconnects to the child process on its known port. So technically you could just have a different port though, one for each player. And like that would solve that problem. I guess that's just not the conventional way to do it. Because ports are like sacred, you know, they're finite. You don't want to just use different ports and stuff. Server accepts a connection and spawns a temporary thread, or puts the socket in a reconnect queue. The server waits for the client to send a reconnect token, match ID, auth token, match ID, player ID, auth token. Server parses and verifies the token, reassociates the socket with the correct player thread. Player 1 to player 2. Reconnection succeeds or fails based on whether the token is valid. The match ID exists. The player slot isn't already taken by another connection. Why this works safely, TCP doesn't care what the connection is for, it just connects. Your application protocol layered on top determines what to do. On top of the TCP determines what to do with that connection. This is standard practice for all online game services that support reconnections. Example code snippet, child process, reconnect handling. Second, server second. Get the reconnect token type plus buffer protection needed in real code. Person to compare the exactly token attach content layer. Okay, yeah, all right, I understand. So you just do connect either way, and then you verify. So this would in terms of this connection function call, it would look like Understanding tokens are types key for building secure multiplayer games, or any client-server architecture with session handling, reconnections, or identity verification. A token is a piece of data sent by a client to prove its identity or session to a server. In your case, game client reconnecting to child process, a token answers, I am player 2 from match 1, 2, 3, 4, and here's proof that I'm allowed to reconnect. Why tokens are secure. Without tokens, a client could just say, hey, I'm player 2 in match 1, 2, 3, but anyone could guess that and impersonate another player. Tokens provide authentication, prove the client who is who they say they are. Tamper protection to players can't change IDs, times, etc. Limit how long a token is valid. Stateless verification. For some token types, no need to store sessions server side. Opaque token. Random UUID. A randomly generated string like that. Server keeps a mapping. Token is associated with match ID, player ID expiration. A client sends the token on reconnect, server checks the mapping and restores the session. So we could just map the player or client ID to the token, right? And then whenever they make their connection, they'll send the client ID and the token. And if the client ID maps to the token, then we'll say, okay, yeah, we know you're actually this client. So yeah, we'll just map. I think we'll do it that way. So include getting port to start the match. Consider switching clarity. Create dict map on server side, linking client ID to to that client's unique token whenever they attempt reconnect. Check if client ID matches the token in the SS dict. If so, allow reconnects. They will send two of client ID token. Simple requires server memory state secure if the token is long and random. HMAC token is a hashed token. Token is created using a secret key the server knows. Example payload. Match ID, blah blah. Then it's hashed. Token equals a base 64 payload plus dot plus HMAC secret key base 64 payload. On reconnect, server decodes and verifies HMAC. No DB lookup needed. All info is in the token. Can be forged without the secret key. Stateless, tamper-proof. Expiry time support. Must keep secret key safe. JWT JSON web token. Standardized versions of HMAC tokens. Header, payload, signature. Contains all relevant info in a base 64 encoded string. Verified via signature. A popular and distributed system. Portable, no server memory needed. Slightly more overhead. Leaking it equals session hijack. Randomness. Self-contained, tamper-proof. Stateless. Secure without DB. HMAC custom or JWT. Signed reconnect info with an HMAC secret key. No need to restore session state server side. Token is validated by verifying signature plus expiration. Clients cannot forge or tamper with it. HMAC hashlib base 64 JSON. Secret key equals B super secret. Generate token. HMAC new secret key. Payload bytes hash lib.sha256.hex digest. Return base 64 b64 encode. Okay, that's kind of complicated. I don't like. I've never fucked with tokens before, but so this is like a learning process for me. But I can. I'm not gonna like deal with that right now. I feel like I learned enough about it to get just a little surface level understanding. Anyway, so back to this. The connection here, what we're talking about on a reconnect, it would say in connect, and what would happen? It would use the network socket, but we actually wouldn't want to use the network socket, right? So the network socket is so this network socket actually would refer to, well, and we wouldn't actually connect, not on the server side. I'm looking at client though. Yeah, we would connect, but so does this? Okay, so it's used by both the server and the client. And in terms of the server side, this network socket would refer to, let's put server first. So server side, the end connect, let's see, dot connect. Where's the accept connection? Okay, so we bind to it. So there isn't actually, yeah, connect, I'm sorry. So connect doesn't actually get used on the server side. We just bind to the server in the port. So we would have to create a new socket, bind to it, and then listen on the server side. So whenever we got to this exception, okay, add code which reconnect client back to thread without rerouting through the main process. So we would need to create reconnect socket. So the S accept returns the tuple con adder. All right, so well, we did that. Um, kind of tired, always tired, whatever. But anyway, we did the thing, and good progress. I don't know, pretty good progress, decent, not the best, not the worst. It's all right. I mean, uh, what can I say? It's always more than what you think. So, you know, you knock out one to do, and then you create like 3 more, but eventually, you know, they get finished. Let me just put a little estimate on these. This is we'll say 30 minutes for that if we do it. Include reconnect port at start of match. That's 15 minutes. That's easy. Refactor. That's probably about, we'll say 30 minutes. Just, you know, it might be 15, but anyway. Yeah, server map client. That's 15 minutes. And then like finishing the. So let's order this. Which one do we want first? Reconnect game. It goes reconnect. Refactor server connect server map client ID one include reconnect sort of match. So we're gonna finish doing the reconnect to game client pi and server pi. That's where we're gonna finish first. And at this point, I would say. Yeah, alright, so there we go. So I would say at least another hour to finish this, because this is kind of complicated. This, honestly, I'm just going to be straight up. This will probably take me another 2 hours to finish. Well, no, maybe 1 hour. We'll say 1. So we're looking at 2 hours 15, 2 hours 45, 3:15. 3:45, 4:15, 4.5. So we're looking at 4.5 to finish these. 4.5. That's pretty good. That's decent, right? So, you know, that's just the way it is. Well, anyway, I'm gonna go. I don't know exactly what I'm gonna do, but it's 4th of July. I might go see some fireworks. They got a massive fireworks show near where I live by the skate park. I'm honestly too tired to skate today. I was thinking about going to the park, but I'm just too fucking tired. I do not think that's gonna happen. Anyway, guys, have a good 4th.